Hello everyone. Today we will discuss the acceleration in terms of the polar coordinate. Earlier you know that the instantaneous velocity in terms of the polar coordinates was defined like v is equal to vr unit vector r plus v theta unit vector theta. Here vr is the radial part of the velocity and v theta is the transverse part of the velocity. Unit vector r and unit vector theta in terms of the time derivative. You also know that your unit vector r dot is equal to, you can write it as theta dot unit vector theta, and unit vector theta dot is equal to, it is equal to minus theta dot unit vector r. Now here we will consider a three-dimensional case. Let us assume that there is a particle placed in three-dimensional space, and this is your x-axis, this is your y-axis, and this is the z-axis. There is a point P. The unit vector along x-axis, let us say it is I, and the unit vector along y-axis is J, and unit vector along z-axis is K. Now acceleration, you earlier know that in terms of the Cartesian coordinates, you can write your acceleration A is equal to x double dot unit vector I plus y double dot unit vector j plus z double dot k. Here x double dot is the x component of acceleration, and it is written as ax. Y double dot is the y component of acceleration, and z double dot is the z component of acceleration. So you can write your acceleration in terms of the Cartesian coordinates like axi plus ayj plus azk. Now we will define the acceleration in terms of the polar coordinate. You know that the instantaneous acceleration, you can write it as dv over dt velocity in terms of the polar coordinates. You can write this expression like d over dt. V is the instantaneous velocity, and it is equal to vr unit vector r plus plus v theta unit vector theta. You can write your acceleration as a in terms of the polar coordinates, like d over dt. It will be vr unit vector r plus v theta and unit vector theta. So acceleration, now you can write it is as d over dt. Vr, you can write it as r dot unit vector r plus d over dt, and you know that v theta is equal to r theta dot and unit vector theta. So here we will use the differentiation formula in case of multiplication. So here acceleration is equal to the first term as it is. Now for the this term, we can write it as differentiation of first term d over dt. Here r theta dot we are assuming it is a first term, then the second as it is, then the first term as it is, and the differentiation of second term is taken, right? So finally we can write your expression in terms of the radial component, like a is radial and transverse component. It will be r double dot minus r theta dot square unit vector r plus twice r dot theta dot plus r theta double dot unit vector theta. Now this part is the radial part of the acceleration, and it is represented as ar is equal to r double dot minus r theta dot square, and a theta is equal to twice r dot theta dot plus r theta. So these two terms are very important in classical dynamics, so you have to remember these. Thank you.